Okay. So it's about 20 years now that I started with the revision of a very small family of fulguromorphs, which happened to be not as small as I expected. So that's a bit of explanation today of where I reached, and especially with that awful genus Platybrachys. So the genus Platybrachys was described by Stål in 1859 to include at the time one species, EURYBRACHIDAE that he had described 5 years before, and some other species that he has described together with the description of the genus. He gave some characters to define the genus. So those EURYBRACHIDEs had no spine under the eye, which is a very strong character of the genus EURYBRACHIS, so the type genus of the family, which is found in South India. So the fact that EURYBRACHID had not that spine was clearly a good generic character at the time. They have the clavus of the tegmina closed, while in some other genera it was open, so again, a good character at the time. The Metatibiae have 3 lateral spines, and the thorax is as wide as the combined length of the probe and mesonotum. So these are very simple characters that make the genus very easy to recognize. It has also short antennae, but well, that's nearly a character that you find in all the EURYBRACHIDs, so that was not such a good character. When you give characters like that are simple, it of course allows to fit a lot of species in that genus. And that's exactly what happened. 21 species have been included in that genus Platybrachys, which is endemic from Australia. They mostly follow the characters that were given for the genus. So the 3 spines on the hind tibiae. You have no spine under the eye, of course, but none of the Australian taxa have a spine under the eye. It's a character of the subfamily EURYBRACHIDAE, which is another one. These belong to the Platybrachinae, which are characterized by the absence of that spine. The character of the thorax, so with the probe and plus mesonotum as wide as long, is shared by all the species there, which are here illustrated by their type specimen. Except for one, which I will reveal to you later, bit of suspense. So that was the situation in 1924. Before Henry Haker had a bit of an insight in that genus. So Henry Haker is a very interesting character. He was an Australian entomologist, but he was born in England. He moved to Australia at the time of the gold rush. He also left Australia at some point to participate in the War of the Boer in South Africa. He collected a lot in Queensland. He was appointed as an insect curator at the Queensland Museum. The beginning of the insect collection of that museum in 1911. He was already aware of climate change, probably because he was mostly traveling by bike. So in Australia, traveling by bike, you can imagine the challenge. So he was going on hundreds of kilometers trips by bicycle. You have a photograph of him there with his net. He used to collect, for example, he was an amazing collector. He used to collect the jiggle beetles, the EURYBRACHIDs, that were flying around the trees by climbing into the tree. with a long handle net and collect them that way, which is, well, quite acrobatic, but that's how he was. Probably the interest in EURYBRACHID allowed him to live long. He died, he was nearly 100 years. So I have some hope to finish that revision. And he published that amazing paper in 1924 on the Platybrachys and company that he had observed around Brisbane. He had done a lot of observation, including the first real observation on the natural history of the group. At that time, all the EURYBRACHIDs were supposed to feed on eucalyptus. Kirkcaldy had published that in his 1906 paper that includes a lot of description of the Australian fauna, and he mentioned that the EURYBRACHIDs from Australia were all on eucalyptus, and if you find them on other plants, it means that they fell from a eucalyptus, which is always a good explanation for everything. So Hacker documented not only the host plants, but also some other behavioral traits, like the eggs and the egg laying behaviors. He also documented the nymphs, the first parasites of EURYBRACHIDs, which were 3 species of HEMIPTERA in the calcidoids that he bred from the eggs. He documented some predators, especially a pentatomid, which is quite common in Australia, that you find on the eucalyptus under the bark very often. And the best thing he did, in my opinion, was that he documented the sexual dimorphism of those guys. So how did he identify his species? Well, he was collecting the specimens, mounting them, labeling them, and then he was sending them to London. He had contacts in London because he had been working at the museum before. And the people in London were comparing his material with the type specimens that were in the collection there and sending him back the identification with the number corresponding to the specimen. And of course, for some of the species, he had male and female that were sexually morphic, they came back with 2 different names. So that allowed him to provide 2 synonymies between Platybrachys decamaculata and Platybrachys decisa, and a synonymy between Platybrachys leucostigma and Platybrachys aerata. So, of course, when you see the specimens and you imagine you're in London and you receive that material from Australia, well, of course, they are so different that they are different species. So, right after Haker, so that's the situation before Haker, and after his publication, there was also a synonymy published by Distant. So, Platybrachys aerata on the top corner became a synonym of leucostigma, which is there. So you see the difference between the male and the female. And the decisa became a synonym of decamacula, which is just beside it. And Distant published a synonymy between Platybrachys rubigenia and Platybrachys barbata. That synonymy is kind of doubtful because it's established on 2 females. So in EURYBRACHIDs, if you don't have the male genitalia characters, you just go nowhere. So publishing a synonymy based on 2 females, that barbata is the first species that was described by Fabricius in that group. It was collected by Banks during the trip of the Endeavour of James Cook. So it's a very old specimen and nobody knows exactly where it was collected. So that led me to try and find some better characters to identify the genus Platybrachys. referring to the type species, of course. So you have upper left a male specimen of Platybrachys lanifera, and you have the male genitalia of that species, and under it a male specimen of Platybrachys florida, and you will see that the common characters are quite easy to see. So all the species in that genus have the hindwings completely brown. They have an apical hook on the anal tube. The Gonostili have a small dorsal hook that's quite reduced. It's at the top angle of the stilus. The phallus has a pair of spinous processes that are and the periandrium has a ventral subtriangular process. It's the triangle you see at the base of the ileus. So those are the very good characters to identify the genus Platybrachys. So from that new definition of Platybrachys, I could remove more species from the genus. So Platybrachys sanguiflua was moved to a new genus, EURYBRACHIDAE. So that genus was named EURYBRACHIS. It was dedicated to a citizen scientist in Australia who helped me to document the host plant of that genus. They actually live on acacia. They are not on eucalyptus at all, or even on plants that are related to eucalyptus. So that guy, Peter Shue, I have to mention him here because he spent 1 month every weekend going with his kids in the forest to try to find those EURYBRACHIDEs on the acacia. And then after 3 weeks finding nothing, I received an email, hallelujah, I have it. So he had found the male, the female, the nymphs, the eggs, and it was on acacia. He found them on 2 species of acacia, so I had the host plant. I have the whole natural history of the species, actually. The other ones that need to be removed from Platybrachys are Platybrachys stellata, down the bottom. That species, well, you immediately see that it doesn't have the brown hindwings, but the genitalia are also completely different from the typical Platybrachys. I transferred the species in a genus that I dedicated to Mary Fletcher, who unfortunately is not with us today. The natural history of that genus is totally unknown. In our recent trip with Linda to Western Australia, end of last year, we've been to the Western Australian Museum, and there they have a quite large series of specimens of that species that were collected surprisingly by pitfall traps. So I have no idea how those guys live and how they can fall in pitfall traps underground. So the genus EURYBRACHIS has 2 species, so sanguiflua and limburgi, that was added together with the description of the genus. Fletcherbrachys stellata is monospecific, and then there is Platybrachys signata that had to be removed from Platybrachys as well, and it was moved to a genus that I named Chemabrachys. Chemabrachys is an amazing EURYBRACHID to me, I hope to you too. The genitalia are just crazy. When you look at the ileus, you see it's just a bunch of spines. So keep those spines in mind because you will need that memory of it later. The type species is a species that was described by Distant from Queensland, Platybrachys signata, And they have a very special biographer with two big lateral lobes. And that's just that character is unique among the EURYBRACHIDEs, but of course that's not all. You have the gonostili that have a super deep incision. It's nearly like they are made from two parts. And they are largely fused on the ventral part. If you look at the Alegus, it has an amazingly long connective that also have lateral processes. And I was wondering, why the hell do they have those processes that I don't find in the other closely related genera? And the explanation came a bit later. Well, a possible explanation, let's say a hypothesis. So the Alegus is composed of two main parts. Alegus sensu stricto, which is finally quite simple. It's a pair of elongated bifid processes, as you can see on the right side there, upper right, and the periandrium, which has all the spines and the Y-shaped process that's dorsal. So I had to map the characters for that genus to be able to describe the 10 new species that I had together with that type species, Platybrachys signata. Externally, all those species look more or less the same. There is intraspecific color variation, so they have black bands that can be more or less developed depending on the specimen. They have the basal part of the hindwing that's yellow or pale brown, and usually they have a white marking or at the apex of the hindwing or in the middle of the posterior margin. Those species, you can only separate them really by the male genitalia. In terms of the distribution, most of the species are known from a single or very few close by localities. There's mostly one species, Platybrachys signata, which is the type species, that's widespread along the eastern coast of Queensland. They mostly follow the dividing range. You find also sympatric species, so within the distribution of Chemabrachys signata, you have two other species that are just there in the middle of the distribution of the common species, but that we didn't find in other localities, despite our expeditions to Queensland. We didn't find those ones in more than one place. So you can imagine, just looking at the map and at the big gaps between the known distribution, that there are probably a dozen more species. That was confirmed by our visit to the Western Australian Museum and the Department of Primary Industry insect collections in Perth. So in each of the collection there was one male and two new species. In terms of their biology, Chemabrachys are extremely cryptic insects on the trunks. They are often living on trunks that have been burnt at some point. So the background is gray, brown, and black, and it perfectly matches their color. They totally trust their camouflage, so to collect them, you just come with a tube and you cover them. They don't move because they are sure that you didn't see them until they realize, shit, that's a tube. That you got them. They live on Myrtaceae, so it's the family of the eucalyptus, but not only on eucalyptus. We have found them on 4 different genera of Myrtaceae. So they are not really host specific in terms of the species of Acacia. So you would be tempted to think that, well, if there is a lot of species, it's because there are a lot of species of eucalyptus, and so each EURYBRACHID will be linked to a species of eucalyptus. It's not like that at all. Clearly, they can be on several species of eucalyptus, and they can even be the same species on several genera of Myrtaceae. Their characteristic habitat is the open eucalyptus woodland. We don't find them in the rainforest, even on the eucalypts that live in the rainforest. We never found them. Now, a little word on the name of the genus, Chemabrachys. The name comes from Kamasutra. And why? Because those guys have a very acrobatic way of mating. Those photos of a mating pair were sent to me by a citizen scientist, Colin Falls, and with her friend Andrew McDougall around Rockhampton. They had photographed some insects on a tree trunk, and they thought it was one insect, and when they looked at the photographs on their computer that they realized, oh, no, it's 2 insects actually. And so as far as I know, they are the only ones mating in that position, and that might explain, that's my hypothesis, I'm happy for you to contradict me, that might explain why they have such a long connective of the eligus and the lateral processes of it that will prevent the eligus from rotating. So the next step for the 15 species of Platybrachys that are still into Platybrachys, there are more species to remove, of course. There's a group of Barbata, Fenestrata, Sicca, that doesn't show the completely brown hindwing. They are mostly translucid in the males and translucid brown in the females. That genus is sexually dimorphic. The males are gray and brown, and the female are reddish brown. So that's one group. There's a second group, that's Platybrachys leucostigma. The hindwings are yellow basally in males and in most females. And then there is one species, Platybrachys maculipennis, in which the thorax is wider than the combined lengths of pro and mesonotum. So from the beginning, that one should not have been placed in the genus Platybrachys and actually belongs to Auchenorrhyncha. So the little things I still have to do is describe that genus that contains Barbata, Fenestrata, etc. And I have 18 new species to describe in that genus. So you see a bit of the genitalia of those guys, what they look like. They're sexually dimorphic, as I explained already. They live on Myrtaceae. They are super well camouflaged. It's like Chemabrachys, you hardly can see them. And the good thing with them is that they are attracted to light traps. So that's an excellent way to collect them when you're too lazy to look at the trunk. The group of Leucostigma is also a new genus, of course, and there is a strong sexual dimorphism. On the top right, you have a male and female of the same species. That's the genus that's the closest to Chemabrachys, and as I told you, in Chemabrachys, the eligus is just a bunch of spines, and here some of the spines are flattened and like laminate. And also, you don't see the gonosteus that's with a deep incision, like in Chemabrachys. My time is over, but I finished. So in Platybrachys, of course, there are more species than what we know at the moment. We have some examples here of the species we have collected during our collecting trips in Queensland with with Linda, there are way more than that. They look the same. In the collections in Australia, they are all identified under the same name. And when you dissect them, it's surprise, we are not all the same. They're quite well camouflaged on the trunks, but not as well as the other ones, so they are more collected, they are more present in the collections. They are not attracted to the light tracks though. So, as a summary, on the left side you have the few things that have been done, and on the right side you have the big things that need to be done, that are in progress. So, from 21 species in a single genus in 1924, we are 1 century later, and we will have more than 150 species in 6 different genera.